Welcome everybody this evening. Our webinar is entitled Lifting the Lid on Cornwall's Space Sector. It is really presented and hosted by Cornwall CETUS stars, and I will give you a bit more information about who they are in a minute. First of all, my name is Dr. Kat Hickey. I'm a Senior Business Development Manager at Goonhilly Earth Station, and I will be hosting sort of the first part of the webinar today. I will get started and I will talk a bit about sort of data capture and movement. We will then cover the sort of launch aspects towards the end of the programme. Hopefully that's okay with everybody. First of all, who are Cornwall CETUS stars? Cornwall CETUS stars is a not-for-profit organisation. We're a handful of individuals. We're dotted all across Cornwall, and we are a project funded by the Royal Astronomical Society for their 200th anniversary. We have a trailer that can go out to schools, village halls, festivals, etc. And we're there to do outreach around astronomy, geophysics, geoscience, space science, satellite communications and related topics. We mostly work within Cornwall, but we can go a bit further afield if need be. Obviously with COVID-19, all our activities have been put on hold and have been on hold for several months now. So we just thought we'd do something a bit different, and we'd host this webinar to really talk about the different aspects of the space sector within Cornwall, and thought that might be interesting to people. We have a few presentations lined up, and then we've got time for a bit of question and answers. All of the attendees' videos and microphones will remain turned off for the time of the webinar, but you should see a Q&A chat option somewhere on your screen where you can pop in some questions, and you can do that sort of during the presentations, but we will likely answer all the questions at the end. We're aiming to do all of this within roughly an hour, and yeah, with that I'm going to say sit back and relax and enjoy the ride. So Goonhilly Earth Station Limited, who are we? For those who don't know, although I expect that many of you do know, we are a large satellite Earth station within Cornwall on the Lizard Peninsula. And actually, if you'd look at my background, I'm pretty much covering where Goonhilly is, so I need to lean towards the side for you to be able to see. Roughly there is where Goonhilly Earth Station is. We've been operating as an independent private company for almost 10 years now, and we've owned the site since 2014. What you can see on the screen here is a sort of an overview of really most of our site, and we can see different types of antennas, we can see lots of solar panels, we've got a data center, we've got a conference center, so we're really branching out from the traditional satellite communications that used to be hosted on site and going into slightly different things. I will mainly talk about the sort of path that data takes that goes through our infrastructure today, but if you've got any other questions, we can answer them in the end, as I said. First of all, let's do a bit of basic satellite 101. For those of you who are within the space sector who know this already, I apologise, but we have a very varied audience today, so I just wanted to make sure that we're covering aspects and we all know what we're talking about when we're using different terms. So what we've got on the slide here is you've got the Earth in the centre, and then I've drawn different types of orbits around the Earth. So there are orbits that are really close to the Earth, something like a few hundred kilometres above the surface, and those are called LEO, low Earth orbits. If you then go a bit further out, you've got your medium Earth orbits, and then if you go even further out, there's a very special orbit around 36,000 kilometres away from the Earth, and that's GEO. When we've got school children visiting the site, I often tell them about low Earth orbit, LEO, and medium Earth orbit, MEO, and I ask them what they think GEO stands for. And quite often the answer is giant Earth orbit. And that's actually not quite true. And obviously the way I phrase it is a bit of a trick question. So GEO stands for geostationary orbit. And in a geostationary orbit, you have the Earth rotating. And at the point where that orbit is, a satellite will rotate around the Earth at exactly the same rate at which the Earth rotates around its own axis. So from the point of view of where we are from the Earth, it looks like that satellite is never moving. That's obviously really good because that means one satellite can be focused over one particular area of the Earth the entire time, and for certain types of applications that's really useful. Just for reference, I've also pointed out that there's something called HEO, High Earth Orbit, which is sort of beyond GEO. And then again, just for reference, the moon is another 10 times further away than the geostationary orbit. There are also things called polar orbits versus equatorial orbits, and that's what you can see in the bottom half of the slide. In a polar orbit, a spacecraft will orbit around the Earth in a way that where it most likely crosses across the poles, or in some plane that is not the equatorial plane. An equatorial orbit, like the name suggests, is a plane that is around the equator or very close to it, and a lot of geostationary orbits and spacecraft within that orbit will also be in equatorial orbits, because that just means that they can maintain that rotation synchronicity around the Earth. Now, why are we talking about different orbits? To give you an example, different types of satellites with different functions might need these different orbits. So what I've got here is a sort of schematic of the ESA Sentinel satellite suite. These are satellites made for Earth observation, and they've got different purposes. So some of them are meant to mainly look at the land, some of them are meant to mainly look at the ocean, and some of them study certain parts within the atmosphere. And you can see on the slide that some of them will be in what we call a LEO, or maybe up to MEO, and then there's one of the Sentinel satellite suites that is in a geostationary orbit, that's Sentinel-4, which is to study the atmosphere. You can also see on the right that I've drawn sort of a rough overview of what the spatial resolutions of these satellites are. That's order of magnitude, so not exact, but you can see that roughly the closer you are to the Earth, the lower your spatial resolution is, so the more detail you can see from a given spacecraft. And I guess that makes sense. If you're closer, then you can see more detail. If you're further away, then you're going to see less detail, but you get a bigger area to look at. A very different example is the SpaceX Starlink, which is a LEO satellite constellation. There's several hundreds of satellites in orbit. They're aiming to launch even more over the coming months. And you can see every little dot on this map represents one of those satellites. All of those are in a low Earth orbit, and they will be providing internet connectivity, and they're really aiming for global coverage for that. So that's very different than the Earth observation that they're doing with the Sentinel satellites, but all of them are applications of satellite technology. How do we fit into the picture? As an Earth station, we have lots of different types of antennas, and these antennas can receive signals from or send signals to these different types of satellites. If you know about frequencies, I've shown a diagram that I've borrowed from ESA. On the left, we can see different bands of satellite frequency and also how they relate to other applications. If you don't know what a frequency is, maybe you're familiar with the waves that we've got in the sea in Cornwall. If you think of the signals from the satellites as waves, which is what they are, and you count the time between one peak and the next peak. So similarly, if you're at the beach, if you count the time from one wave arriving to the next wave arriving, that gives you a measure of your frequency. Frequency is measured in hertz, and so 1 hertz is 1 peak per second. What we're seeing here actually, and for satellites in particular, is usually on the order of gigahertz. So you have kilo, mega, giga, and every time you add a factor of 1000. So for example, if we said 1 hertz is 1 per second, a kilohertz is 1000 per second, and then it goes up by factors of 1000 from there. So those frequencies are really, really high, but that's the kind of spectrum that satellites work in. And with our antennas, we're able to receive those signals or send them for different types of application. The types of data that we might be sending or receiving can roughly be split into 4 categories. The first one, which is a very important one, is telemetry, tracking and control, or telemetry, tracking and command, as it's sometimes referred to. And that's essentially making sure that the satellites are doing what they're meant to be, looking at the sort of health status of the satellite, making sure that all the instruments might be functioning properly, making sure they're in the right orbit. So effectively, we're flying the satellites for the satellite operators. There might be audio and video data being sent, for example, for broadcasting purposes. A lot of you might have a little satellite dish on your house. That satellite dish receives your TV signal, so that's a broadcasting application, but that signal might come from a big Earth station like we are. You might be wondering about which type of satellite those broadcasting satellites are on which type of orbit. If you think about the satellite dish on your house, that never moves, which means it always points at the same point in the sky. And that's because the broadcasting satellites are typically in a geostationary orbit, so that satellite dish on your house doesn't have to move. I already mentioned satellite internet, for example, through the Starlink constellation. And then there might be things like high resolution imagery, which is what the example of the ESA Sentinel suite was. So we can look back at the Earth, do something called Earth observation, and get really good imagery for analysis, for Earth signs, for hazard monitoring, for commercial business applications, freight, ship tracking, etc. There are lots of different applications for this, and we can essentially facilitate that data exchange through the antennas that we have on site. I've shown here just an example of a few different types of antennas. On the left, you have our two largest antennas, Goonhilly 3 and Goonhilly 6. Both of them are being repurposed at the moment for both deep space communications. So that's being able to send signals from and to deep space missions to the moon, missions to Mars, asteroids, other places, and also radio astronomy. So that's a more scientific rather than a commercial application, but nevertheless, we can do this type of work with the antennas if the infrastructure within the antennas is set up properly. On the right, you can see what we refer to as the antenna farm. In the antenna farm, we have also different types of antennas. We have antennas that are stationary, so focus on one point of the sky, and those are for geostationary orbit applications. But we also have an antenna there that's very flexible, that can track across the horizon really quickly, and that's meant for low Earth orbit applications, where because the satellites are closer to the Earth, the time it takes for them to move across sort of from one side of the horizon to the other is much shorter. So we need smaller but also more flexible and fast moving antennas, and we've got some of those on site as well. In terms of size, the antennas range from anywhere between sort of 1 meter all the way across to 32 meter, which is our largest antenna. So it's a broad spectrum of sizes as well. Just an example of some of these Earth observation applications. I'm just showing a couple of examples. I imagine Alice, who will be talking after me, will also have a few more applications for you to look at. But what we can see here is actually a set of images that was acquired by the Sentinel-2 satellite, and we can see an area of wildfires in Greece that was affected in 2017. One is actually a sort of true color image, and we can see the actual fires and the burnt area, and then the other one is a false color image, and we can actually see the burnt area even better in this type of image. So that's just one example of where we might be using Earth observation. Another example here from Landsat 8, which is a US-owned satellite for Earth observation. This is an area of flooding in Puerto Rico. I can't quite remember the year that this happened and the imagery was acquired, but you can see really well, for example, in the sort of bottom right of the image, the areas of this part of the country that were affected by this flooding. So again, the sort of hazard monitoring is a really important application. What we're doing on top of this, so we've got the antennas and they can send data back and forth, make sure the satellites are flying properly, and if there's data being gathered, we can downlink the data. At the end of this, we have a newly developed data center, so we can actually look at data storage, but also data processing. And as part of this, we're just in the process of launching the Goonhilly Space AI Institute. What we're looking to do here is really to encourage collaborations across sectors where there might be applications for artificial intelligence within one sector, and they might be really well developed, and they might actually be able to help another sector as well. So with that, we're hoping that we can add new collaborations, sort of push artificial intelligence and machine learning within Cornwall, and we can back that with the data center infrastructure that we have, but also with the antennas and our proximity to data coming from space. So really that combination of the antennas in the AI Institute enables us to cover the complete life cycle of data coming from space, all the way from sort of, you know, a mission where you might be launching a satellite and you need to command that satellite, you need to make sure it goes into the right orbit, to then making sure it stays in that orbit, everything is functioning properly, downlinking any data. We can then use the data to actually use them for certain types of application. An example that you may have seen in the news, and I've shown a bit of an image here, is some work that we did with the University of Hertfordshire, where they're using some knowledge they've gained within the field of radio astronomy, and they're applying that and sort of artificial intelligence algorithms that they've developed to Earth observation data, so the kinds of data that I've shown in the previous slides, where there's often a problem that the Earth is covered by clouds, and the land surface that we might want to see, we can't see because we can't see through the clouds. And so they're using some radio astronomy techniques to essentially predict away the cloud cover, and that way they make the Earth observation data a lot more useful. That's just one example, but it sort of really gives you a good idea of that sort of final step of the life cycle of this kind of space data that we might be facilitating through Goonhilly Earth Station. And with that, I think I am ready to hand over to my colleague Alice Bird from the Southwest Centre of Excellence in Satellite Applications.
My name's Alice. I'm the mining lead from the Southwest Centre of Excellence in Satellite Applications, which is kind of like a regional branch of the Satellite Applications Catapult. So I'm just going to give you a bit of a background on the Catapult and the Southwest Centre, and then I'm going to talk more about those applications that Kat mentioned before. We're a not-for-profit, partially government-funded innovation organisation. So we're basically just here to help various companies and different organisations to access space tech and the support that they need to start engaging with the different technologies that's currently available. We've got loads of different partners and companies that we work with. So the headquarters of the Catapult is based in Oxfordshire, but we've got a regional centre, so you can see us there down in the southwest. We've got the northeast and south coast centres as well. We work very closely with the Space Agency, the UK and the European Space Agencies, and there's loads of different space hubs all across the country. But as for the Southwest Centre, it's mostly partnered with a few different universities. So the University of Exeter, which is me, the University of Plymouth and Falmouth, and we've got members on the team from all of those different universities, as well as different associates. So, you know, we've got Goonhilly on there and Spaceport, our other speakers, but we also work with Aerospace Cornwall, Cornwall School of Mines, TEVI, Space Agencies, again, loads of different partners. So there, you can kind of break space tech into two parts. You've got your upstream space tech and your downstream. So upstream is anything from manufacturing, so building the rockets in the first place, robotics, that could be lunar rovers, things like that, to launch services, and downstream satellite applications, which is mostly what we do. So the three main categories of downstream satellite applications are Earth observation, which we've already mentioned a bit, communications, and then sat-nav, which I'm sure you've all used yourselves. In the Southwest Centre, we mostly focus on 4 different themes, but that doesn't mean that if you're working in a company or you run a company that doesn't get covered by one of these 4 themes, it doesn't mean that we can't support you. So bear that in mind, but we do focus largely on health and well-being, marine and maritime applications, which is very relevant to us down on the peninsula, mining and geoscience, as I said, I'm the mining lead, and then natural capital as well. So that can be everything from agriculture to forestry. So I'm going to talk a bit more about some of those themes. So in the extractive industries, which I'm heading up, we can do a few different things, mostly environmental baseline monitoring. So, you know, assessments of pre-mining environments, using imagery to provide environmental insights, facilitating social engagement, so developing tools to generate stakeholder trust, and operational efficiency. So that could be anything from, you know, making sure that your mining equipment isn't spending too much time down and providing information about the most efficient routes around site, that kind of thing. And I'm just going to mention a few case studies. So one that you may or may not be familiar with down in the southwest is the company Cornish Lithium, who have been spending a few years now looking for lithium resources in Cornwall. So using satellite data, we were able to generate some great targets. So the project, which was in 2018, used novel satellite techniques to create a lithium prospectivity map in a certain area of Cornwall, including an environmental baseline study. So the kind of satellite data that we were using and applying to this was alteration and mineralogy anomalies, structural controls. We were looking at vegetation from space, so you may know that sometimes the vegetation can reflect the geology or some contamination in the earth. So using those data sets from space, from satellites, in combination with pre-existing geological maps and mining data and archives like that, they were able to create a lithium occurrence map, which then was proved successful when Cornish Lithium went and drilled in the areas highlighted by this satellite-based map. So that was a very successful campaign, and just one example of what you can do in mining and geoscience. But another example would be our autonomous mining robots. So this is a project that we're working with at Campbell School of Mines as well. So the purpose largely of a mining robot would be to reduce human risks. So using autonomous vehicles which are led by satellite navigation and SATCOMs can reduce human risk by taking people out of extreme mining environments. So this could be for things like mine inspections after blasting, sample collections and other analysis, and the robots equipped with LiDAR cameras, LED array tools, which eventually, when the project is finished, it's still very much going at the minute. This could increase income for mining operations and also reduce risk for people that work there. But moving on from my own theme of mining and geoscience, let's move on to health and well-being. So our lead on that theme is Anna, and some of the different things that she works on would be emergency responses, improving efficiency of ambulances and conveyancing, managing long-term conditions, and also pollution hotspots. So reducing pollution-related conditions by using air quality satellite data to give tailored advice to patients. And some of Anna's really exciting projects that she's worked on now and in the past include the Connected Healthcare Project. So this investigates the impact of rurality on healthcare. So this is a project between Cornwall and Scotland, which, as we know, are very rural areas, and increased population and disease pressure on healthcare systems, and a reduction of the rural healthcare workers has led to an impact on health for the people in these rural areas like Cornwall and Scotland. And this project optimises satellite connectivity and space tech developed by the space sector to support the care for isolated patients. And then a very different but very interesting project was the AID-GI and the PILCAM projects, which enables preventative endoscopy screenings for patients. So this stands for Artificial Intelligence Supported Diagnostics of Gastrointestinal Diseases, very catchy. And the project is set to decrease time spent analysing capsule endoscopy videos while it improves the quality of the images. And that is a follow-on project from the PILCAM project, which is what this image is. It's just a small capsule containing loads of cameras, and it can pass through a patient in just 8 hours and collects 50,000 images from their own home and transmits that via satellite technology to experts for analysis. So this could save millions for the NHS, reduces burden on resources, reduces space in hospitals for patients that would need this kind of treatment, but then also can reduce carbon because of the thousands of patients that will no longer have to travel to hospital, and the same for the doctors who might be able to just stay at home in future. And then our next theme, I think the slide doesn't want to move on again. No, we're with it, it's okay. We've got marine and maritime. So our marine and maritime lead is Chloe, and she focuses on offshore renewable energy development, coastal and species monitoring, and cybersecurity applications. One of her main projects really is the Cybership project. So this is all about raising shipping's cyber resilience. So every shipping vessel has these similar basic bridge equipment that rely and have always relied on satellite connectivity and technology associated with satellite data. And the University of Plymouth has a new £3 million cyber ship lab. And the purpose of that is to raise shipping cyber resilience to be more in line with more cyber aware sectors such as banking, because at the minute, you know, shipping is very vulnerable to cyber attacks and cyber threats. So the purpose of this lab is to build resilience to those system vulnerabilities and develop mitigation measures for technical and human perspectives, and all of that relies on SATCOMs. And another project, which is perhaps more obvious, is the CETUS USV project. So this is autonomous vehicles, basically. So CETUS itself is an unmanned marine vessel capable of conducting research off the southwest coast, provided to University of Plymouth students and staff, and local businesses in the area as well. And this can give people the opportunity to conduct innovative research in the smart sound of Plymouth. Offshore proving area is reliant on satellite-enabled technologies for navigation, the communication, and the vessel is just a great example, really, of what unmanned vehicles could be like in the future. And not on any particular theme, I just want to mention our Space Tech Incubation Program. So this is a business support program to accelerate space ideas. So if you're sitting there in the audience and having seen a few of the examples of what space tech and satellite applications can do, and you have an idea that uses space tech or satellite data, Earth observation, navigation, or satellite communication, then do get in touch, because hopefully we'll be running some of these incubators soon, and the programs can offer expert business monitoring, pitches to space agency and investors, follow-on business support and funding opportunities as well. So thanks very much for hearing all about our space tech applications, satellite applications in the Southwest Centre. I've got some emails down there, so if you're looking for mining and geoscience, get in touch with me. Maritime and marine, it's Chloe, and health and wellbeing leaders, Anna, or anything that doesn't fit under those categories, you can get in touch with Conrad, who is our centre manager. Thanks very much.
Great, thank you very much, Alice. My name is Dave Pollard and I am the Education Outreach Manager at Spaceport Cornwall. So I wanted to start off with some space sector stats locally. In the last 12 months, there have been 5,249 jobs in the space and aerospace sector in the UK. In the last year, the amount of jobs have increased by almost 57% UK-wide. It's a fast-growing, exciting sector. The Southwest was third highest area nationally for the amount of space and aerospace jobs advertised in the country, with an average UK salary of £40,000. Most jobs in the space and aerospace sector require a degree, so 62% required a degree level or higher qualification for the jobs that were advertised. And the top 5 requested skills were teamwork, project management, budgeting, stakeholder management, and engineering. This is data that's come from Labour Insights Burning Glass Technologies from November the 1st, 2019 to October 31st, 2020. So very up-to-date information. So I'm here to talk to you about Spaceport Cornwall. So what is Spaceport Cornwall? Spaceport Cornwall is a project that has been supported by the UK Space Agency, Cornwall Council, Virgin Orbit, the Local Enterprise Partnership and Goonhilly Earth Station. And we will be launching rockets from Cornwall Airport Newquay. And Cornwall Airport Newquay has been chosen to host Spaceport Cornwall because it's got one of the longest runways in the country. It's got a largely uncongested airspace, and it's quite a rural area. But one of the most important things is that it's got direct access over the sea. So it makes launching rockets a lot safer. We've got a partnership with Virgin Orbit, who will be looking to launch horizontal spacecraft in 2022 using this is a retrofitted Boeing 747 and called Cosmic Girl, and the Launcher 1 rocket. And the rocket that we see there is about the size of 2 of our red double-decker buses, and it fits under the wing of the plane. The plane flies up to a very high altitude, and the rocket will drop and launch into the orbit. And the benefit of this type of launch is that we're able to launch into many different orbits and be very quick to act if different companies need satellites launched, because the plane can fly to different trajectories and different areas of the world to launch the rocket. So this is hopefully what we're going to see, and the reason for this increase in satellite launch, you may have seen a lot of news recently about satellite launches around the world, is because satellites are coming down in cost. And they're coming down in cost because they're also coming down in size. You can now launch a satellite for under £1 million, which is substantially cheaper than it has been in the past. And this is one type of small satellite, which is what we'll be looking to launch from Spaceport Cornwall. And this is a CubeSat. And the estimates vary that we're within the next decade we're going to need somewhere between 13 and 30,000 more small sats launched to help satisfy demand and support us in developing in the future. And Kat's already covered a lot of this about the different orbits that there are. We're talking about low Earth orbit satellites, so launching satellites into low Earth orbit. And this is less than 2,000 kilometers, but can be as low as 160 kilometers. And the space station is an example of a low Earth orbit satellite. These satellites tend to rotate around the Earth a lot faster than the Earth rotates, and are generally launched in constellations, so that there's always a satellite over a given point on Earth at any one time, so that data can be transferred. And low Earth observation satellites can be used for things like navigation and for internet communication, but also for low Earth observation. And these are some of the examples where low Earth observation can be used. So within our farming communities, there's an area called agri-tech and agri-farming, and they could be used to look at a farmer's fields and inform them about what crops may not be performing so well, where targeted chemical applications or fertilizer could be used, so that a farmer isn't going out and fertilizing the whole field, maybe focusing on one specific area that needs it, so reducing costs and increasing yields. Can also be used to track illegal fishing. So it's always been traditionally very difficult to see where different ships in different countries are fishing, but using satellite data, we're now able to track a lot more closely where different ships are and where different boats are and what they're doing. So what's the opportunity for Cornwall? The UK government has targeted the UK with capturing 10% of the global space market. So we're looking at £40 billion for the UK by 2030. At present, not too many people know this, but at present the UK manufactures a large proportion of the world's satellites, but we have no current launch site. And the market generally and the sector generally is growing at a fast rate. Specific opportunities, Spaceport Cornwall will create 150 jobs, with more than 80 expected to be for local people. Most importantly for me, I think it's about the opportunity to create a space cluster down here for other companies and organisations to think about investing and developing down here, and for young people or for business people to develop space companies. You know, Alice has told you about some of the support that's out there already, and there's a great amount of support for space sector organisations, including Aerospace Cornwall as well. This is the start of the space cluster, this presentation today. You know, we've got a runway and a spaceport with us and Cornwall Airport Newquay. We've got an aircraft and a rocket through Virgin Orbit. We've already got world-class mission control facilities and data capture through Goonhilly Earth Station, and we've got the satellite applications catapult for helping businesses get off the ground. But one of the most important things to me as the education outreach manager is the opportunity to inspire a generation of young people. So the graph that's on screen here, this is the change in studying levels, studying STEM subjects within the US during the Apollo program, and they saw a marked increase in students studying STEM subjects right up to the highest level. So by STEM I mean science, technology, engineering and maths. And I like to talk about STEAM, so that includes the arts within the STEM subjects. And when I'm talking about arts, it's about the ability to think creatively and to solve the problems that we're going to have going forwards as a world, and also, trying to launch these satellites to space. How do we make it cheaper? How do we make them more efficient? And how do we solve problems like the debris that's left in space in the future? And in the art and the creative aspect of thinking is really important to all of that. So with Spaceport Cornwall, this is the plan that we have going right from primary level to post-university. So at primary level, we're talking about some inspiration space broadcasts, and to develop resources and comics that will be freely accessible. We're hopefully looking to develop our first apprenticeship in the next year or two, and that would likely be a marketing and project support apprenticeship, and working right up to that post-university level, so setting projects for Launchpad students who are based at Falmouth University, and looking at developing that cluster further. So making sure that young people can see, really clear progression routes right all the way through their education. If we do have any teachers or schools or anybody involved with schools that wants to get in touch with me afterwards about this, my email's on the last slide, so please feel free to get in touch because I'm developing these at present. We're also talking about future job opportunities, and when we're talking about job opportunities, I'm not really talking about the astronaut side, which comes up a lot when I'm speaking to students, but more talking about sort of the spaceport operations, spaceplane and rocket systems, payload integration and propulsion systems, and also aerospace engineers. It's widely known that engineers are in short supply in a lot of sectors, and we need engineers to solve the problems, to build the products that we're putting up, and if we can enthuse more young people about engineering as an opportunity, whether or not they go into the space sector it's not essential, but we need them as a country and as a world, really. And then, as Alice mentioned, I think there's huge opportunities around the downstream application development, and if we can get companies using that data that comes down from space in a commercially clever way, then I think there's massive opportunities, because you can do that from anywhere in the world, so why not do it in Cornwall? Within Cornwall, we've seen a 164% increase in space sector organisations since 2010. So we've now got more than 50 businesses and more than 250 employees in the sector. In 2018 and 2019, it had the highest average salary in Cornwall. We've got high year-on-year growth and a really wide range of job opportunities, both upstream and downstream. I wanted to give just a quick update of what's been happening with us recently. So we've started demolition at the airport and the build of the payload integration facility, which is really exciting. We're looking to launch our mascot within the next couple of weeks, and that mascot will be used to present some of the primary broadcasts and really enthuse that younger age group, rather than having an old dollar like me talking to them. We've also advertised and are at the final stages of recruiting our operational manager role, which will be based at the airport, and we'll be working with partners internally to make the launch happen in 2022. And we've been consulting on a new UK space agency consultation on liabilities, insurance and charging. So lots of developments taking place, and a really exciting. It's just a really exciting time, I think, for the Cornish space sector and developments here locally. There's my email if anybody wants to get in touch afterwards. david.pollard@spaceportcornwall.com, and I think we're now going to lead into the question and answer session. I know there's a 10-second lag on this, so. We'll start going through some of the questions that have already been submitted, and we'll try and go for the ones that have been voted as the highest.
I can start to answer one of those questions. One of them was about Goonhilly Visitor Centre. That's a question that we get asked a lot. We do still have the visitor centre facility, but at the moment it's not really safe for use. and it is part of our business plan, not within the next few months, but within the next few years, to be able to bring that back up to speed and really get an exciting visitor centre up and running. But it's not something that's going to happen in the immediate future. So if you're planning your holiday to Cornwall for next summer, I think I'm going to have to disappoint you and say we will not be open just yet.
Cool, thanks, Kat. I've got an anonymous question here. So do all of these satellites cause any issues for astronomers? Don't they look like stars? Yes, there is some challenges with astronomy and the satellites being launched. Especially initially, once you may have seen some of the SpaceX launches. Initially, once they're launched, they're very low Earth orbit, and then they'll rotate into a further out orbit. There is good technology now around being able to plan where those satellites are coming around, and if you want to be looking at the stars. And I think there's also some developments around launching telescopes on satellites, so that you don't have all of that sort of interfering with what you're seeing. I do think there's a huge opportunity for astronomers to work with satellite companies to try and make satellites as invisible as possible. So maybe making them as dark as possible and as unreflective as possible. So that could be an area where astronomers get involved with satellite organisations. Sorry, Kat.
I'll just jump in here. There's a question that's actually really important to this webinar, and is how can secondary school students get involved with the space sector? Again, that's a question that I think all of us get asked quite a lot. Dave already mentioned some of the opportunities that they're working on from a Spaceport Cornwall perspective. From a Goonhilly perspective, we typically offer a year 10 work experience and a year 12 summer school. As you can imagine, with the current pandemic, we're not in a position to offer those, but we are looking to get programs like this back up and running as soon as it's safe to do. In general, I will say, though, that for any particularly slightly older secondary school students, it's always worth, if you want to do a bit of work maybe over the summer holidays or something, there are lots of different types of programs that you can apply for. There are, for example, the Nuffield Foundation offers internship or placement opportunities, and those then will be with companies, for example, within Cornwall. But even if you haven't got an opportunity like this, it's always worth just reaching out to a local employer and say, I'm really interested, these are my skills, maybe if there's something specific that you think you're really good at. And I think employers do appreciate if somebody's really proactive, whether that's for a placement or maybe for something like an apprenticeship that will follow on from your school career. So that's a very good question and a very important one.
I will also just add to that in that we're taking part in a virtual work experience placement programme through the Careers Hub as a pilot, and if that's successful, then I will look to run another one in either February half term or the Easter holidays for students who are interested, and that will be more around sort of space entrepreneurship, but will hopefully be a useful insight into the space sector. So keep your eyes peeled on our social media for that, because that's probably where we'll be sharing that opportunity in the future. Or if drop me an email and I can send you the details on about that. I've got another sort of student related question, and that's is there a role for humanities students in the space sector? I mean, Alice, I don't know if you want to take that, because I think a lot of the work and some of the projects that you shared are kind of humanities based.
Yeah, sure. When you say humanities, you mean like history and like modern languages and philosophy and stuff? I would say there is probably room for everyone. If I think about the different types of people and the different sort of skill sets that people have at the catapult, for example, there's all kinds, and you don't have to be an aerospace engineer or even a geologist or some scientist of some kind to work here. We've got loads of people who do everything from project management to marketing to graphic design. and all of these things for all of our space projects. I know all kinds of people with different backgrounds, and maybe if you are coming from a humanities background, then there will likely be something that you can do in space tech, and once you've got your foot in the door, it's a great world to be in. So I would say, yeah, keep your eyes peeled. There's loads of different stuff out there.
I would maybe add to this, there's been another question that kind of relates, and it is, are there ethics guidelines in relation to satellite use? So the answer to that is there are some guidelines. There's, for example, the United Nations Outer Space Treaty, which is a treaty that countries can voluntarily sign up to, and it sort of governs some of the regulations around how we use the space that surrounds our planet. However, that treaty is not really a recent thing. It's several decades old, actually, and so there's definitely room for thinking about how the use of space can be regulated. That's not just the sort of space in the different types of orbits that we discussed, but will then also later apply to things like once private companies go onto the moon, for example, how is that regulated, etc. And obviously the kind of regulations around that, the thoughts behind that, the ethics, so those guidelines there, I think is lots of room for humanities to play a role in that. Similarly, there's something called space situational awareness, which is all around how we look at different objects that might be orbiting around the Earth. How do we regulate what companies put up? Does it come back down? When does it come back down? Where does it go? Do we know where things are moving around? And I think also in that field is sort of a heavily engineering dominated field, but I think there's also space in that for humanities to play a really important role.
Thanks, Kat. We've got another question sort of on that as well, is that I've heard that the atmosphere is becoming crowded with the remains of previous satellites, which could prevent future missions. Will there be any programs in the future to clean up the Earth's atmosphere? And I think that's a real growing area of first commercial business, but also of thought, because there is a lot of debris up there, from minuscule flecks of paint to large satellites, and there are companies, one company, Astroscale in Oxford, who are set up specifically to look at how we can clean up space, and whether that's pushing some of that debris further out into orbit, so that it essentially orbits away from the Earth, or if it's bringing it into our sort of burn-up zone. So, I mean, if that's an area that interests you, I would strongly advise following that interest, because I think it's going to be a hugely growing area in the future.
It's worth adding that most of the orbits that we're talking about actually sit beyond the Earth's atmosphere, because the question was sort of about the atmosphere. If a satellite were to be in what we consider the sort of, the biggest part of the atmosphere, as Dave was pointing out, there's so much friction with the molecules of that atmosphere that those objects or spacecraft effectively would burn up. And that's why a lot of particles that we have in certain types of orbit, as they come lower and as they come back into the atmosphere, do burn up and don't actually fall back onto the Earth. That's also the reason why, for example, crewed spacecraft coming back to Earth need really, really effective heat shields and need to be engineered in a way that they don't burn up on re-entry into the atmosphere.
Great, thanks, Kat. I've got a couple of questions in the list. Will Virgin Galactic be launching from Spaceport Newquay in the future? Currently, there's no plans for space tourism, the movement of people, but you never rule that out within the long-term, distant future. Looking at how things are developing, who knows what will happen in the long, distant future. I've got another question here about the. That one's been answered. So, is the technology able to identify the old disused mine shafts that blight areas of Cornwall? I am not too certain on that one, but I don't know if Alice or Kat.
Yeah, I can probably tackle that one. So, was the question tackling blight or tackling or spotting mine shafts, or both? So
spotting mine shafts that blight areas of Cornwall.
Okay, so it's obviously there's loads of different. I think the figure is something like only 20% of the historical mining infrastructure of Cornwall is actually mapped. So there's a lot that we don't know, and obviously the satellites are already out there. And if there is a way to find them using space tech, which is obviously non-invasive, so we don't have to dig up people's gardens to go and find mine shafts, then using space tech is a great way to do it. There's loads of different things from radar to find anomalies in the surface and things like that, and other things that maybe they would use in archaeology and geophysics methods like that, which is probably more aero rather than satellite data, but still sort of relevant. And obviously you can kind of use, as I kind of mentioned with the lithium project, there's loads of different methods even for looking at historical mining landscapes. Like there's a lot of other things that you can look for that aren't a physical shaft. So you could look for areas of contamination. So you know, a lot of the chimneys that you have around Cornwall there, arsenic heavily, like they would be arsenic flues, and there's contamination and stuff like that are in those areas. So there would possibly be vegetation anomalies and loads of different anomalies like that you could look for. So locating historical mine sites is something that I do think is possible, is probably being done. And I know that there are companies like Mining Searchers, for example, whose job it is basically to go out and find that kind of those kinds of sites. And I know that they use space tech and satellite data already. So yeah.
Great, thanks, Alice. I think we've got time for sort of one more question. There's a question in the sidebar about kind of how is Cornwall viewed within the space sector and the space cluster. I've got to say, I think it's viewed really positively. When I've attended international events, there's a lot of awareness and excitement about the developments within Cornwall. And whenever I do, well, especially when I do school presentations, there's huge excitement about the opportunities that could be here in the future. And Kat and Alice have probably got things to add in from their side as well.
Absolutely. There are, maybe to add to this, this is more on the line of, because I see a lot of questions are coming in about how can we get involved in the space sector in general. This might be for young people, but also for people transitioning from other sectors, people with specific skills, asking about when particular jobs will be available. From a Goonhilly point of view, I can only say that we're always interested to hear from people and to hear what kind of skills they have and how they think they might be able to contribute to our business. We've just launched a new website, so if you go to goonhilly.org, if you've visited our website in the past, but maybe not over the last couple of weeks or so, you'll see a completely new layout. And if you go into the careers section, there's an encouragement for you to drop your CV, drop us a line if there's anything in particular you're looking for, or if there's anything that you want to discuss with us. And I'm sure with Spaceport as well, Dave was sort of outlining some of the roles that will become available. But just if there's anything specific you're wondering about, just get in touch with us and we're happy to start a conversation. I think with that, unless there's any other sort of very general kinds of questions, we probably need to wrap it up. Yeah, Dave, go ahead.
I just want to say a quick thanks to Laura Philpott from the Cornwall and Isles of Scilly Careers Hub, who's helped the back end of this today with the broadcast. And this is the first of a series on lifting the lid webinars around different sectors. So if that interests you, do get involved with that. And a huge thanks to you, Kat, for organising from CETUS Stars point of view. It's been a really great presentation. Apologies again about not being able to get Virgin Orbit on, but we will share that, and they were really disappointed not to be able to talk to you all.
And then maybe just to add as a last comment, we apologise that we didn't get around to answering all questions. There are a lot of them and we're just a bit constrained by the time, and obviously our aware is the evening and some of you might have families to get back to and other responsibilities. If there are other burning questions that you really would like to have answered that we didn't get to, please feel free to get in touch, either by email or, you know, ping us a message or drop us a little note on social media if it's something that you think other people might be interested too, and we'll try to answer those kinds of questions that come trickling in just over the next few days, hopefully. And with all of that, I want to say thanks to our attendees as well. It's been really great to have all your questions and to see that you're also interested, and hopefully we'll be able to engage with you further as we continue on this epic journey. Thank you very much.
Thank you so much for having us. We are Virgin Orbit. My name is Michael Thomas, and I'm the head of affordability. I'm also the Virgin Orbit Risk Officer for Spaceport Cornwall project. I'm joined here today with my colleague, Kendall.
Hi guys, my name is Kendall Russell. I'm the Communications Officer here at Virgin Orbit. And we just have a little presentation. We're going to talk a little bit about our rocket, about our company, and the capabilities that we're hoping to bring to Spaceport Cornwall really soon.
Great, let's dive right in. Our founder is Sir Richard Branson, and he has two space companies, one on the left, Virgin Orbit, and the other is Virgin Galactic. As mentioned, we are Virgin Orbit, and we are focused on launching small satellites from our rocket system. Next slide. This is our great and amazing Virgin Orbit team. This photo here was taken in our Long Beach, California facility, and we are a cool and fun bunch of rocket scientists, engineers, business folks, communications folks, and we all come together to build our amazing Launcher One rocket. Here's our integrated rocket system. Here you see Cosmic Girl, which is a modified Boeing 747, also known as our flying launch pad, and on the bottom there is our Launcher One rocket. And that rocket we build, test, and manufacture right here in Long Beach. I really wanted to take the time to show you a photo from our first demo flight that happened back in May. This was taken at the Mojave Air and Spaceport. As you can see, Cosmic Girl released our rocket and our Launcher One system ignited. Over to you, Kendall.
Yeah, so just to talk a little bit about the rocket itself. So Launcher One is a two-stage expendable rocket. It's about 70 feet long and weighs about 57,000 pounds when fully fueled. That's a little bit over 25,000 kg for our friends over there in the UK. So those dimensions sound quite large on paper, but actually the rocket is fairly small, especially when it's under Cosmic Girl's wing. The 747 is just such a huge plane. It's a really easy task for it to lift our rocket. Our propellants are LOX and RP1, LOX just being simple oxygen that's cooled down until it's liquid, and RP1 is essentially just a refined kerosene. So on the next slide, you'll see our Newton 3 main stage engine, and that generates about 75,000 pounds of thrust, which is about as much power as a nuclear power plant, but it only operates for about 3 minutes, which is just enough time to get that rocket into the edge of space. After stage separation, our Newton 4 engine, which looks a lot like Newton 3, but just smaller, it ignites, and that'll help circularize the orbit. Newton 4 operates for about 6 minutes total, but it usually burns in a couple different burns. So it'll stop, and then it'll reignite depending on where exactly we need to go in space. As Michael had mentioned, we do all of our manufacturing in Long Beach, California. And so from the very beginning, we've been doing a lot of work in parallel. We've been we've been developing the design of our rocket while also commissioning our carrier aircraft, while also establishing our manufacturing facility. So 3 parallel streams of work there. And so when we conducted our first launch demo, we wanted our next rocket to already be basically fully built. And coming up on our next demo, we're planning to do the same. So basically, we're implementing an assembly line style of manufacturing, and right now we have about a half dozen rockets in various stages of production. Ultimately, we want to work up to something like 20 rockets per year out of this manufacturing space alone. And here's just another photo showing what that factory looks like. So all of these elements combined, they enable a capability that's called responsive launch. Air launch really makes it just so much easier to target any orbit on any schedule that our customers desire. So one of the biggest beneficiaries will be constellation operators. And constellations are just large networks of small satellites that work together in tandem. And so with air launch, you can quickly and affordably replace one satellite in a network, either because it's been disabled, it's lived out its lifespan, or maybe you just want to refresh the technology that you have on orbit. And so that capability has proved to be very attractive to government, to civil, and to commercial customers, both in the US and abroad in places like the UK. So one thing I wanted to touch on is sustainability, because being a company within the Virgin family, we really strongly believe that business must serve as a force for good in the world. So, while we're launching satellites into space, and that's really fun and cool, we take sustainability very seriously because we want to make this world a better place for us all. So the FAA, the Federal Aviation Authority, which is our main regulator in the US, they recently conducted an independent environmental assessment of Virgin Orbit's operations, and that found that our ops are not expected to have a significant negative impact on the environment. In fact, it can be argued that the biggest environmental impact we'll have will be the lessons learned from the satellites that we launch. One of the biggest pushes in satellite missions right now is finding ways to better monitor climate change. So you can do that by taking photos of the Earth. You can take photos of the Earth's poles over time to calculate how quickly the ice is melting. You can monitor and predict the impact of natural disasters. You can even monitor changes in agriculture in places around the world, which is super valuable for all sorts of different industries. At the same time, satellites also allow us to work more efficiently on the ground. And my favorite example of that is how airlines and ships use satellite data to navigate more fuel-efficient shipping routes. And so all of that information is really valuable, and we have a number of such missions on our manifest right now. As for space debris, which is another huge issue of concern right now in the industry, our own materials, which is basically just the upper stage, will re-enter into the Earth's atmosphere and burn up within 5 years. And that's a lot better than the 25-year standard, which was set by the United Nations. We've also recently committed to carbon renewals in the form of regenerative agriculture projects. And so this is just the beginning of our sustainability initiative, and we have lots of other plans and work that we're excited about. But we just wanted to emphasize how much we care about keeping our environment as green as possible. Even while we're doing all the good for the space industry, we want to make sure that we're having a positive impact back on Earth as well.
Thank you so much, Kendall, for that. And now we wanted to show you just a little bit how we prep our rockets for shipment. So this photo here is in support of our upcoming Launch Demo 2 mission. And essentially, this is how we prepare our rocket for transport. Here's a couple of other photos here. As you can see, we've loaded our rocket onto a tractor trailer so that it can be transported to our Mojave facility for final testing and checkout. Also here, this is a photo of Cosmic Girl along with Launcher 1. And as you can see, there's a suite of ground support equipment, and that equipment will enable our mobile launch. And here at Virgin Orbit, we are here to create the new normal for launch, bringing horizontal launch capabilities around the globe. And that concludes our presentation. Kendall, anything further to add?
No, I think that just about covers it, Michael-Lynn. I hope you guys enjoyed the presentation. We're happy to answer any questions that you guys have, so feel free to reach out. Again, my name is Kendall Russell, and I'm joined by Michael-Lynn Thomas. If you have any questions, just reach out, or you can reach out to Spaceport Cornwall, and we hope to see you guys over there in the UK very, very soon.
Cheers, bye.